What this question wanted you to do is graph each one separately and describe each one from the previous one. What we're going to do, though, when we actually graph these is we're going to think about our original graph. There's our original graph. And then say, how can I use my original graph to graph all of this at once? And when we look at this, we're going to go from left to right and label all the different things that we see. So as I'm going from left to right and saying, what's different from the regular absolute value graph to what I have here? Well, I have a 1/4. That 1/4 is outside of my function. That's telling me something's going to happen vertically. In this case, it's going to be a vertical compression. We're going to multiply our y values by 1/4. Then we run into this 2. That 2 is inside the absolute values, so we know that that's going to be horizontal. And everything that's horizontal is a little bit opposite of what you see. So instead of multiplying your x by 2, you're going to multiply your x by 1/2. That tells us that that is a horizontal compression. The +3, that's going to be a horizontal translation. That horizontal translation is going to move things 3 to the left. And finally, the +4 is going to be a vertical translation. Now, how we go about showing this and what we're going to do for graphing is we're going to first graph our parent graph. So off to the side, over here, I'm graphing y equals the absolute value of x. I know that 0, 0 is a very important point on this graph. It has a bunch of other important points as well. 1, 1, 2, 2, 3, 3, 4, 4. There's a lot of points that are going to happen, but that key point 0, 0, for sure you're going to use that. Now, what we're going to do to graph all of this at once is similar to what we were doing with our stretches and compressions, where we drew an arrow to see where things would go, but this time we're going to have 2 sets of arrows. We're going to do all of our stretches and compressions first, and then all of our translations after. So the first arrow will do all of our stretches and compressions. Well, we had a vertical compression that says, that blue arrow says we're going to multiply y by 1/4. We have a horizontal compression that says we're going to multiply x by 1/2. Horizontal translation, in the second arrow we're going to say we're going to go 3 to the left, and the vertical translation says we're going to go 4 up. So when we combine all of our transformations, we're going to look at specific points and do all of our stretches, compressions, reflections, everything that is multiplied first, and then everything that is added and subtracted, all of our translations second. So with 0, 0, multiplying by things isn't going to change that. That's still going to be 0, 0. But then if I go 3 to the left, -3, and 4 up, I'll end up at -3, 4. When choosing a second point off of my blue graph, you can choose any points you want. You can choose 1, 1, or 2, 2, or 3, 3, or 4, 4. However, sometimes there's a point that's going to allow you to run into less fractions. Sometimes fractions are unavoidable, but if you can avoid them and use whole numbers, it just makes graphing easier. Can you see that if I choose 4, 4, that would be a good choice because I'm going to have to multiply my y coordinates by 1/4. And if I did 4, 4, well, y by 1/4, that's going to be 1. X by 1/2, that's going to be 2. I stay with whole numbers. Then 3 to the left, -1, and 4 up, -1, 5. Similarly, I might choose the point, if I want one on this side of my vertex, I might choose negative 4, 4 as another point as well. Multiply my y by a quarter, my x by a half, then move it 3 to the left and 4 up. Draw some grid lines on our graph here. Label these points. So I've got negative 3, 4, negative 1, 5, excuse me, and negative 5, 5. Since negative 3, 4 was my vertex, I know that my graph looks like this in the end. So when we have all of our transformations together, we look at key points that were on our original graph, and we do stretches and compressions first to see what happens after we multiply, and then translations at the end to see what happens after we add or subtract. And so this graph was compressed vertically, compressed horizontally, then translated to the left, and finally translated up. And this green graph is the final image of what this blue graph was to start with, after it was moved over. Connecting this to something you've done before, right? Can you see this is very similar to what happened with your parabolas, that your vertex matches up with moving 3 to the left and 4 up? And with a parabola, though, we only dealt with vertical stretches. We never had horizontal stretches in our parabolas because they weren't really necessary. Now we're going to have all of these things happen with our different graphs. We are going to move forward to example 1. They give us a graph of g of x. We want to sketch and label the graph after a vertical compression of 1/3 and a translation of 2 units up. So we're going to take all 4 of the key points on here, negative 5, 3, negative 2, negative 3, 1, 0, and 4, 6. We're going to set it up. Again, the first set of arrows are for vertical stretches, or all stretches and compressions. The second set of arrows are for all of our translations. And then we're going to label above those arrows what we need to do. So I'm going to label, you don't have to label this every time, but just for your notes right now, that I'm going to label that first set of arrows as stretches. Now, stretches will also include compressions and reflections, but so we don't have to write out a ton of stuff. We'll just write stretches. This first set of arrows is whatever we're multiplying by. And then our second set of arrows is translations. Translations are when we add or subtract things. So when we look at this question, we do have a compression. So above this first arrow, I'm going to write my y values are compressed by a factor of 1/3. I'm going to write y equal by 1/3 above that. We don't have any horizontal stretches or compressions, so that's the only thing that's going to go over that first arrow. Then we also have 2 units up. So that second arrow is where we're going to show that translation that we're going to go 2 units up. Where do these points end up? Well, let's multiply all of our y coordinates by a third. So our x values aren't going to change. It's simple mental math, but take your time and check your answers after each one. Because it's simple mental math, like, ooh, what do we have to do next? We have to add 2. Adding 2, I don't know when the last time you really struggled with adding 2. Probably has been maybe grade 2, maybe grade 1. It's been a long time. So we have the tendency when we do something really easy to not concentrate and let our brain wander. Some things that are going to happen to your brain is you're going to say, oh, add 2, and you're going to start off good, and then on the next one you're going to add 2 to the wrong coordinate because your brain is like, this is easy. Be careful. Pay attention to detail because you will make tons of little mistakes in this unit. And so I just want you to focus because it is easy to make those mistakes. And I will make them here as well. So if you see me make a mistake up on the board, sometimes I'm thinking about the next question or what I want to show you next, and my brain starts to wander, I'll make those mistakes as well. So now that we've got all of our new points, we can label them -5, 3, that's going to end exactly where it started, -2, 1, 1, 2, and 4, 4. Join our points together. And ask yourself, does this look like it's been vertically compressed, squished towards the x-axis first, and then translated 2 up? Does it seem reasonable? Because that's the last sort of check that you can do when you've got your points. Does that seem to be what happened? In this case, I would say yes. That's what looks like has happened. Now, this question doesn't ask for the equation in terms of g of x, but we're going to do it just to practice. So if g of x is our original function, and we want to write the equation of our blue one in terms of g, we need to show y by a third and 2 up. Those are both vertical transformations. They're going to be outside of our function. So the y by 1/3 will be outside of our function. The +2 to go 2 up will also be outside of our function. So this would be the equation of the blue graph in terms of g. Normally we just do the question off to the side, but there's something special that happens in the original question. So we'll go through this one as well. I'll do it exactly the same way. They've got the answers there in your textbook written out. Sometimes the textbook's methods are just a tiny bit different. But for this one, you can just watch. You don't have to write anything down. Until maybe the end when we write our equation, I'll focus you at that point. But same thing. I'm going to take the points that were given. So we've got -4, 4. 0, -2, 2, 5, and 4, 2. I'm going to set up my arrows for my stretches, compressions, reflections, and then set up my arrows for my translations. In this one, we want a horizontal compression by a factor of 1/2. That tells me above here, I'm going to multiply my x values by 1/2. And then we want to go 3 to the left. So above this one, I'm going to label 3 to the left. Now it's just our mental math where we don't want to make any mistakes. X values by 1/2, so take our time. Y values don't change. Did you see it? I didn't notice it until I checked it over. Because while I did it, was the same thing I was saying. Easy to make a mental math error. Do you see my mental math error? For whatever reason, I don't know why, I don't know which buttons I'm pushing up there. This is the one I want. This negative shouldn't be there, right? Your brain will just do that. I think my brain probably saw this negative and said, man, I made a nice cute little negative on that number above. I sure like that, and just added that negative without even thinking. Okay? I didn't do that on purpose to like show what I was talking about before. It's like, oh, here's a good example. No, that was pure mental math mistake going along. Now 3 to the left, again, that's affecting our x values. -5, y values don't change. -3, -2, -2, 5, and -1, comma 2. Draw these points. Where are they going to go? We're at -5, -4, -3, -2, -2, comma +5, and finally -1, comma 2. Connect your dots. And ask yourself, does that seem reasonable? Does it seem like it's been compressed by half and then moved to the left? Yes, that seems reasonable. Now the reason I really wanted to show you this one is because writing the equation for this is a little bit interesting. I'm going to show you one equation in black and one equation in green. Do not write them down. One of them is right and one of them is wrong. But I want you to think about, what would you write if you had to write this on a quiz or a test? Because if your gut is telling you something now, it'll probably tell you the same thing later on, and you want to see, is my gut reaction right or wrong? Because I want to pay attention to that right now. So you could write this as y equals, in terms of f, everything is inside the function. So I'm going to show you two options, one in black, one in green, where everything's inside the function. In order to have x by a half, there needs to be a 2 inside. That would be the same in both of those equations, because that's what a horizontal compression by a half. You have the reciprocal inside your function. Now 3 to the left is going to be x plus 3. So we have two options. Either I can put that x plus 3 in brackets or not put it in brackets. Think about how you would write it on a quiz. If you were asked to do this right now, would your gut have told you to do it as the black or as the green? Okay? I've had students say explanations in the past. Some people say, I'd pick the black one because it looks nice and simple. Okay? Some people say, I wouldn't pick the black one. It looks nice and simple. Math is always hard and complicated, so it must be the green one. And so they go through all these mental dilemmas. The answer is the green one. It has to be written factored out. If we look back to the only hint you would have had for this one is to look back to our very first example that we did in our notes here, and notice here the x plus 3 is factored out. That 2 is outside. So there was your hint, how much attention you were paying to those little details at the beginning. Probably not that much. But in this one, we have to write it this way. So what I want you to do is at the bottom of the page, write this special note. When we have, and I'll put this in capitals, a horizontal, and I'll write them all out, either a stretch or compression or reflection, anything that multiplies, with a horizontal translation, you must write it in factored form. And that's going to be hard to remember. I had a student once who, whenever I had hard to remember things, what she did is she set a reminder on her phone, and I think she set this one at 10 p.m. Every night, this special note came up on her phone. Remember, when you have a horizontal. And so, I don't know how many of these reminders she did by the end of the year. It's like the last hour before bed is just like a constant barrage of math for things that you have to remember. It's like, oh, go away. But she did have this one up so that by the end of the year, she was like, yeah, I just knew that so well because every night I sent myself a reminder. Because this is one of those things that is going to be hard to remember. And it comes up all over the place that it's hard to see. So she set that up as a reminder so she could remember it by the end of the year.